All right, let's continue our discussion on lesson 3.1. And this time we are moving on to the greatest common divisor. Actually, most of you know this as the greatest common factor. So factor, divisor, pretty much the same. Okay, so pretty much when we are finding the greatest common factor, we write any number into its prime factorization form, and then we identify which prime factors are found in both of the given numbers. Okay, now if the GCF of two numbers is 1, like meaning they don't have any common factor except for 1, they are what we call as relatively prime. Okay, so let's have an example here. Let's take the GCF of 216 and 234. So let's do the prime factorization of 216 first. Okay, and over here on this side we have 234. So 216, if you divide this, okay, so we can have it divide by 2, okay, since this is even. So you divide it by 2, then this would be going to be 108. Okay, now 108, as we can see, again, it's even number. So we can divide it again by 2, okay, and this could now be divided as 54. All right, oh, sorry. We circled the prime numbers, okay. 54 can now be factored out as 9 and 6, okay. 9, oh, sorry, my bad. 9 is not a prime factor yet, okay. Sorry about that. 9 is could still be divided to become 3 and 3. So 3 and 3 are now prime. 6, on the other hand, is 3 and 2. Okay, so that's the prime factorization of 216. 234, all right. Similarly, we can use 2 as our first divisor since it ends with a 4. So 2 is here and it's a prime number. So if you divide this by 2, this is going to be 117. Okay, now with 117, now it's going to be tricky. Okay, now aside from this is not an even number, it doesn't end with 5 or 0, so definitely not divisible by 4. So the next thing is, let's try to add the digits. Okay, 1 plus 1 is 2, plus 7, 2 plus 7 is 9. Okay, so if the sum of the digits is divisible by 9, is a multiple of 9, then you can divide this by 9. Okay, or you can have it as, so if you divide this by 9, this is going to be 9 times 13. Okay, now 9 could be simplified to become 3 times 3, which are both prime numbers. 13 is already a prime number. Okay, so how do we identify the GCF? My suggestion is you can write them down again in horizontal form and make sure that you align the factors that are common so you can easily find them. Okay, so let's take a look at 216. How many 2's do we have? We have 3 2's. 2 times 2 times 2, and then we have 3 3's times 3 times 3 times 3. Okay, 234 on the other hand, how many 2's does it have? It has 1 2. So I will have 2 times, okay, how many 3's do we see here? We have 2 3's. So these 3's, I will not put it here. I will put it right under the other factors that are 3. So 3 times 3, okay, and then we still have the 13. It's not like any of this. So times 13 is over here. So in this case, you can see which are the common. And that is, this is common, 2 times 3 times 3. Okay, so the GCF is 2 times 3 times 3. And this is going to be equal to 2 times 3, which is 6. 6 times 3, which is equal to 18. All right, so 18 is our GCF. Okay, oops, sorry. Let's have the next example. Sorry, not the next example. Before I continue with the other example, let's talk about LCM first. So LCM, least common multiple. So the simplest way to explain this is a common multiple of the two numbers that is the smallest possible. Okay. So what you can do here is you can also use the prime factorization. All the common factors will be counted as one time only, and then you multiply all of the remaining factors to get the least common multiple. So let's have an example, okay? So let's have 144 and 300. Okay, so if we are to visualize this, okay, when we talk about list common multiple, you list down all the values if you multiply 144 by different numbers. So 144, 288, what's next one? 3 times 3, nope, that's gonna be 4 times 3, so that's gonna be 412, and so on and so forth. So if you keep on adding 144, that's gonna be that. 300, what are the multiples of 300? That's gonna be 300, 600, 900, and so on and so forth. So where we're looking at is when will you get that common number in this list, okay? But instead of us having to how do you call this? Instead of us needing to list them down, we can use prime factorization to make things easier for us. Okay? So let's work with our prime factorization. We can start with 2. Okay, since this is an even number, and this is going to be 72. 72 could be split into 8 and 9. 8 could be split into 2 and 4. 2 is already prime. 4 could be split to become 2 and 2, which are both prime. On the case of 9, this could be split to 3 and 3. Okay, therefore, these are the prime factorization of 144. 300, on the other hand, easy divisibility because it ends with a 0. So we have a 10 and a 30. We can simplify 10 to become 2 and 5, which are both prime. 30 could be written as 6 and 5. 5 is already prime. 6 could be split between 3 and 2. All right? So, if we're looking for the LCM, okay, when we talk about LCM, so we list down our prime factorization, similar to what we did with GCF. So how many 2's do we have here? There's 4 of them. So 2 times 2 times 2 times 2. And then we have 2 3's times 3 times 3. We align the prime factors of 300. We have 2 2's. Okay, 2 times 2 times. How many 3's? We have 1 3. And then we have 2 5's, which is not present in 144, times 5 times 5. Okay? If we are looking for the GCF, okay, let's use a different color. If we're looking at the GCF, it's going to be 2 times 2 times 3. So 2 times 2 is 4 times 3. So 2 times 2 times 3, that is going to be 12. But because in this problem, we are looking for the LCM, we will need to multiply all of these factors. So this is only counted one time. So 2 times 2, which is 4, times 2, 8, times 2, 16, times 3, 16 times 3 is 48, 48 times 3, that's going to be, I forgot, okay. So 48 times 3, so that's going to be 24, 144, 144 times 25. If you multiply that, that value is going to end up as 3,600. So if you remember the list earlier, 144, 288, blah, 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 300, 600, 900, the first time that they will be the same is when you hit 3,600 on the list. Okay? So let's have another example on this case. Let's have 360 and 500. All right. So easy division here by 10. Okay, and then 10 will be 5 and 2 primes. So 36 will be 6 and 6. This is 3 and 2. 3 and 2. All right. 500, again, 10 and 50. 10 is going to be 5 and 2. Okay. 50 is going to be 5 and 10. And 10 is going to be 5 and 2. All right. So listing down our prime factorization, 360 and 500. How many 2's? 1, 2, 3. 2 times 2 times 2. We have 2 3's times 3 times 3. And we only have 1 5. 500 has how many 2's? 2 of them. 2 times 2 times. We have 2 5's. 1, 2, 3. 3 5's. 1, 2, 3. Okay. So, what is our GCF? Our GCF is what is common. So, the common is 2 times 2, which is 4, times 5. So, that will be 2 times 2 times 5, which is 20. That's the GCF. LCM, on the other hand, is the product of all of this. So, 2 times 2, which is 4, times 2, 8, times 3, 24, 24 times 3, 75, 72, 72 times 5, that's gonna be 172 times 5, I think that is 360, 360 times 25, you will end up with 9,000. Okay, so that is how you can find the GCF and the LCM of any given pair. Okay, so one application of using the LCM is like this one. So we have a movie theater that runs its films continuously. Okay, one movie runs for 80 minutes and another movie runs for 120 minutes. Now, let's say both of them begin at 4 p.m. Okay, when will the movies begin again at the same time? Okay, so you can see that the length of the movie are different, and so we need to find the LCM of both of these numbers. So if we look at 80, this is gonna be 20 times 4, and this is 5 times 4, and this is gonna be a 2 and 2. 5 is already given. 4 is also a 2 and a 2. Okay, 120 on the other hand is gonna be 12 and 10. 12 will be 4 and 3. 3 is prime. 4 is gonna be 2 and 2. 10 is going to be a 5 and a 2. Okay, so we need the LCM. When can we find them the same time to play again? So in this case, you have 80 and 120. You have 4 2's, 1, 2, 3, and 4, and 1, 5. You have 3 2's, times 2, times 2, times 5, and then you have a times 3. Okay? So, in this scenario, we only need the LCM. When will they be common again? Alright? So, in this case, it will be 2 times 2 times 2. So, 2 times 2 times 2 times 5. That's the GCF. Okay? And then you have times 2 times 3. Okay? So, we have 2 times 2, 4 times 2, 8 times 5, 40, 40 times 2, 80, 80 times 3 is 240. So after 240 minutes, and what is this equivalent to? 240 minutes, we know that 1 hour is 60 minutes. This is equivalent to 4 hours. So after 4 hours, these two movies will play again at the same time. So at what time will it be? So 4 hours plus the 4 o'clock p.m. So that would be at 8 p.m. So this is an example of how we can use LCM in real life scenarios. Thank you.